Section 2 in Chapter 9, we're going to talk about prime and composite numbers. So we'll explain what those are if you don't know. That's okay. That's what we'll focus on today. So first of all, I'm pretty sure you've done factor trees before for numbers. Factors are numbers that multiply together to create one another. So for example, 2 and 3 are factors of 6. 1 and 6 are also factors of 6. So let's see if we can write all the factors of 12. So one easy way to do it, in my opinion, is just to show what numbers would multiply, and we're just dealing with whole numbers and only positive numbers. Can you write all the numbers that multiply to equal 12? So I always recommend you just start with number 1. So you say, okay, 1 times 12 would equal 12. You say, okay, 2 times 6 equals 12. And there's 3 times 4 equals 12. And you could say, well, yeah, 4 works too, but we've already listed 4. So if you start at 1, as soon as you find a number that you've already listed, you know you're done. So there's no reason to also write 4 times 3, 6 times 2, and 12 times 1. That's redundant. It's just adding the same, or including the same numbers all over again. So that's a benefit of just starting with 1 and working your way up. And this is a completely fine way to write the factors. But another way you can, if you want to, is just write them in order and say, okay, 1, 2, 3, 4. Because I could say, does 1 go into 12? Yes. Does 2? Yes. 3? Yes. 4? Yes. 5 doesn't. So I'd skip 5. 6 goes into 12. 7, 8, 9, 10, 11 don't. But obviously 12 can go into itself. So you can do either one of these forms and get full credit for that. Okay, now here's the definition of a prime number. A prime number is a whole number greater than 1, so 1 is not a prime number. Make sure you understand that. 1 is not a prime number. So a whole number is a number greater than 1 whose only factors are 1 and itself. So 3 is a prime number because 3 times 1, or 3 and 1, are the only factors of 3. So it's a number whose only factors are 1 and itself. So pause for a second and see if you can think of 3 other prime numbers. Okay, some easy examples would be 2, because the only things that go into 2 are 1 and 2. 5. Only thing that go into 5 are 1 and 5. 7. 11's another. 13's another. And so on. Now they only ask for 3. I just kept going. We'll talk more about the prime numbers on the next page. Or on your sheet it might be the right half of the page. But anyway. So that's prime numbers. The only thing that can go evenly into a prime number, the only factors it has are 1 and itself. Now, composite numbers. They're a whole number greater than 1 that has more than 2 factors. So it has factors beyond just itself in the number 1. So 4 is an example because yes, 1 and 4 do go into 4, but so does 2. So another way we could say it is prime numbers are things that only 1 and itself go into. Composite numbers are not prime numbers. Things that the factors are itself, 1, and at least one other number. It may be a lot more numbers. But let's think 3 composite numbers. Again, I'd encourage you to pause, see if you can think of 3. Okay, so I listed 4. 6 would be 1, because 1, 2, 3, and 6 all go into it. 8 would be 1, because 1, 2, 4, and 8 all go into it. 9 would be 1, because 1, 3, and 9 all go into it. 10 has 1, 2, 5, and 10, and so on. Now one thing I'll go ahead and tell you, every even number except for 2 is a composite number, because every even number that's higher than 2 it can always be divided by itself, by 1, and by 2. Now, there are plenty of odd numbers that are composite. I'm not saying evens are and odds aren't, but every even number except 2 is composite. And some odds are composite, some odds are prime. There is an exception. Number 1 is neither prime or composite since its only factor is itself. 0 is also neither prime or composite. And if you look back at the definitions, it says whole number greater than 1, whole number greater than 1. So that's part of why 1 is not included in either one. So 1 is neither. It's the exception. So circle the prime numbers and box in the composites. Let's not worry about boxing the composites. We'll just know we'll circle the primes. And I am going to cross out number 1 just because it's neither. It's the exception. So pause again, see if you can circle all the prime numbers. So it turns out 2 and 3 are prime, 4 is not because 2 goes into it, 5's prime, I'm going to skip the evens because I know they can't be prime, 7's prime, 9 is not because 3 goes into it, 11's prime, 13 is prime, 15 is not prime because both 3 and 5 go into it, 17's prime, 19's prime, 21 is not because both 3 and 7 go into it also, 23 is prime, 25 is not because 5 goes into it, 27 is not because 3 and 9 go into it. So those are the prime numbers for 1 through 27. Okay, now let's list the factors of these numbers. I'm going to use the multiplication method, but if you like just listing them from largest or smallest to largest, that's okay. So I'm going to use my method of starting with the number 1. So 1 times 24, 2 times 12, 3 times 8, 4 times 6. But I can't use 5 because 5 doesn't go evenly to 24. 6 is a factor, but we've already used it. So we can stop right here because basically once you hit one that's on the right side, you're just going to loop back around and hit these same ones again. So 40, same method, we'll start with 1 and 40, 2 and 20, 3 will not go into it, 4 will, 4 times 10, 5 will, 5 times 8, 6 does not, 7 does not, 8 does, but I've already listed it. So I'd like you, if you can, pause and try these next two on your own. So for 100, we get 1 and 100, 2 and 50, 3 doesn't work, 4 and 25, 5 and 20, 6 doesn't work, 7 doesn't work, 8, no, 9, no, 10. 10 times 10. Okay, one note I want to make. Like I said, either one of these methods is fine. There is nothing wrong with listing 10 twice when you're doing the multiplication method, because otherwise you're not showing what times what equals the 100. So this is completely fine that I duplicated 10 here. But you would not want to duplicate 10 if you're just listing numbers this way. Well, and since we've already got 10 on the right, we know we can stop there. Once you hit whatever times itself equals 100, you're good. 60 has a lot. This is one reason they think people chose to make time 60 seconds, 60 minutes, and all those things, because 60 has a lot of factors. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, okay, 7 no, 8 no, 9 no, 10 yes, but we've already covered number 10. Okay, so this is all the numbers 1 through 100. There are 25 prime numbers 1 through 100. So this is very similar to what we did on the first page but we did it with just 1 through 27. So let's go ahead and cross off number 1 because we know it's neither. And let's just do what we did in the front. We'll just say circle prime numbers, and we'll just not do anything to the composite numbers. So if you want to try, please feel free to circle all these and go that way. If you want to pause that, you can do it. But I'm going to show the answers to you in just a moment. But I'd encourage you, if you want to challenge, see if you can find all 25 numbers between 1 and 100 that are prime. Okay, now I want you to either check your work or fill this in. Now this answer sheet's in blue, but the blue is the prime. That's what you need to mark. So circle or mark all the ones in blue. So 2, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. If I'm going too fast, feel free to pause. 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. So you do not have to memorize all 25 of these, but certainly the lower ones, I'd say maybe like 1 through 50, it'd be good to have those familiar to you. I don't mean you have to list them, but just read them enough so that you can pick up on it if you're asked about them. Okay, last page. Going to work on some of these factor trees. So find which prime numbers multiply together to make the original numbers. You can find the prime factorization by creating factor trees. Okay. One thing with factor trees, remember 1 is not prime. So there's no benefit in writing 1 times 24 is 24. You always want to pick a number bigger than 1 to start with. Unless it is a prime number, then there's not really anything else you can do. Okay, but 24. So it's fine to start small. Like I might start with 2. I know 2 times 12 is 24. But I can stop right there because that's already a prime number. So I don't need to go any farther on this side of the tree. But 12, I can say 2 times 6. Again, I've got a prime. But 6 can go farther. It's 2 times 3. But both those are prime, so I can quit there. So you split the number into 2 numbers. It's possible neither will be prime, in which case you keep going on both. In fact, I'll try to show that right here. But when you have a prime, you can just circle it and know, okay, the tree stops there, then keep growing that way. So the prime factorization would be 2 times 2 times 2, because I've got 1, 2, 3 2s, and 1 3. Okay, now here's another way you could do it, and both of these are correct. I could say 4 times 6 is 24. Now neither of those are prime, so we keep going. 4 is 2 times 2, both prime. 6 is 2 times 3, both prime. But I wanted to show you this so you can see that there is more than one way you can correctly factor it. And sometimes you get a prime right away, sometimes you don't. But either way, our answer is 3 2s and a 3. So now let's try the same process with 100. So you can think, what are 2 numbers that multiply to be 100? Now you can pick 2 and 50, you can pick 4 and 25, you can pick 10 and 10. I'll just pick 10 and 10. Now neither of those are prime, so I need to split them up further. 10 is the same as 2 times 5. Those are both prime. Well, and that's the same number, so I just repeat 2 and 5. And those are both prime. So we have 2 2s and 2 5s, which we can write that way, or we could write it as 2 squared times 5 squared. Either way. Okay, 240. Now let's say you're like, that's a big number. I'm not sure what to do. What I'd recommend is if it's an even number, just start with 2. And you're allowed to use your calculator to help you from there. You can say, all right, 240 divided by 2, that's 120. 2's prime, so that branch will stop. 120 is the same as 2 times 60. Here's a 2, that branch will stop. 60 is 2 times 30. 30 is 5 times 6. And 6 is 2 times 3. So if you look, we have a total of 1, 2, 3, 4 2's, 1 3, and 1 5. Or we could write it as 2 to the 4th times 3 times 5. Okay, now this is important. Make sure you understand this. They will often ask you to do prime factorization when variables are involved. And for whatever reason, when there are variables involved, they will not want you to do any exponents in the answer. So for the number part, we'll do the same thing we did up here with these. No difference in how we do the number part. But in our answer, we'll have to do this expanded version and not use the exponents. So let's just do the number, then we'll talk about the variable. So 96, that's the same as 2 times 48. 2's prime. 48 is 2 times 24. 2's prime. 24 is 3 times 8. 3's prime. 8 is 2 and 4. 2's prime. And 4 is 2 and 2. So we got a lot of 2's. So 1, 2, 3, 4, 5 2's. 1, 3. And because there's a variable of x, we just put times x. So the variable part really doesn't make it a whole lot more complicated. You'll just need to include the variable, or as we will do in the next one, you have to expand that to say y times y, because y squared means y times y. 46. Now that's even, so I'll divide it by 2. I get 2 and I get 23. That was quick. Those are both prime. So I would write 2 times 23, and then y squared I expand to be y times y. $700. Okay, I'm going to think 7 and 100. 7's prime. 100 I'll use 10 and 10. Neither are prime. 10 is 2 and 5. 10 is 2 and 5. Those are all prime. Now, a question you may be asking, I can't remember if I mentioned this earlier or not. It's not technically required to do them from least to greatest, but I am going to ask you to do them from least to greatest. I don't plan to count off if you don't, but I'm just saying, I know we kind of got them 7, 2, 5, 2, 5, but it's best to write 2 times 2 times 5 times 5 times 7. Then we have 2 A's, so times A, 3 B's, B times B times B. Okay, 350, got 7 times 50, 7's prime. 50, we got 5 times 10, 5's prime. 10 is 2 and 5, and those are both prime. So I have 1 2, 2 5's, and 1 7. Then there's 4 X's, 2 Y's, and 1 Z. So expand the numbers just like we do on the numbers by themselves with factor trees, but don't use exponents on these. And then expand the variables out to as many as are needed based on their exponent.